Hello everyone. Today we are going to learn theorem 1.2 and 1.3. So let's start. Theorem 1.2 is let P be a prime number and if P divides A square then P divides A, where A is a perfect integer, where A is a positive integer. Okay. So what it is saying is કે કોઈ P છે એ એક prime number છે. We know prime numbers કે 2, 3, 5 which has only two factors, one and the number itself. So if P divides A square, if P છે એ કોઈના squares ને perfect square number હોય એને divide કરતું હોય, then P divides A also એ number ને પણ divide કરતું જ હશે. Okay, where A is a positive integer, A છે એ કોઈ positive number છે, we will not take negative numbers. Okay, let's take one example. Let P be a prime number છે તો P we are taking as a number 3. So 3 જે છે, okay, is a prime number that divides A square. We are taking one perfect square number. Let's take a number 81. 81 is a perfect square of 9, we know. So when 81 we divide by 3, what we get is 27. So 81 is divisible by 3. Therefore the perfect square of 9, 81 is a perfect square of 9, એટલે 9 છે એ પણ 3 થી divide થાય છે. Okay, we know 81 is a perfect square. When we divide 81 by 3 we get 27. So 81 is a perfect square of 9, એટલે 9 when we divide by 3 we get perfect number is 3. So 9 is also divisible by 3. It means this again, that if P is a prime number, that is 3, P divides A square, 81, then P divides A also. So this theorem will be applicable in theorem 1.3. Now let us start theorem 10.3, which is most important. It is going to be there in your board's exam. In section C there will be 3-mark question, so please make sure that you do it. Root 2 is irrational. Okay, root 2 is an irrational number, we know. Okay, so what we will do is, on contrary, we will assume that it is a rational number. Okay, so let us assume on contrary that root 2 is rational, and we know all the rational numbers we can write in fraction form. So root 2 is equals to A upon B we can write, where A and B are co-prime number and B is not equal to 0. If denominator will be 0, then the number will be imaginary and we cannot say it is a rational number. This is what you have to write. It is compulsory. Okay, we have to mention. Now if we multiply B with root 2, what we get is B root 2 is equals to A. Why we are not writing B behind root 2 is, maybe if we do a root, अगर root છે થોડું મોટું કરી દઈએ તો b છે એ root ની અંદર આવી જશે, then it can be also root 2b. Okay, under root 2 and b both will be under root, એટલે b ને આપણે compulsory આગળ જ રાખ્યા છે. B root 2 is equals to A. Now what we'll do next step is કે squaring on both the side, બંને સાઈડ ઉપર square કરી નાખીએ. So what we'll get, b નો square શું થઈ જશે, it will be b square, and root 2 square will be 2. So 2b square, when we are writing numericals and alphabeticals, we always prefer કે numericals આગળ આવે, એટલે we will write 2b square is equals to A will become A square, as we are squaring on both the side, equally left side and right side. So here what we can say is કે 2 છે એ b square સાથે multiply માં છે, will go in division. So we can say કે A square જે છે is divisible by 2. So A is also divisible by 2 as per theorem 1.2. what we discuss કે કોઈ perfect square number, કોઈ number prime number થી divisible હોય, then that number is also divisible. So here same thing is applicable કે A square is divisible by 2, where 2 is a prime number. So A is also divisible by 2. We will mention as per theorem 1.2. We can also take A equals to 2C, as A is divisible by 2. So all the numbers of 2 will be divisible by 2. So we can also write A is equals to 2C for some integer C. C is any number 1, 2, 3 કાંઈ પણ લઈ લઈએ તો A છે એ એનાથી divisible જ હશે, because 2 ના multiples, it will be 2, 4, 6, 8, તો એ બધા divisible જ આવશે, as we just saw કે A is divisible by 2. So by substituting A is equals to 2C in this equation, what we will get is A 2b square is equals to a square. It was 2b square is equals to a square. A square ની જગ્યાએ what we will write is we will substitute 2c. So what we will get is 2b square is equals to a square ની જગ્યાએ 2c square લખીએ છે. So it will be whole square. આખા a ની જગ્યાએ 2c ને replace કરીએ છે, તો it will be 2b whole square. 2c whole square. 2b square as it is equals to, अगर bracket open કરીએ then 2 square will become 4 and c square will be c square. So when 2 is goes in the division, it becomes b square is equals to 2c square. So here again what we can say is કે આ 2 જે multiply માં છે will go in division. It is of course divisible, તો જે equal થતું હોય. So we can say that b square is also divisible by 2. And so again as per theorem 1.2 what we can say is that b is also divisible by 2. Here we will mention as per theorem 1.2. This means that a and b both have 2, at least 2 as a common factor, as a is also divisible by 2 and b is also divisible by 2. So what we can say કે a અને b બેયને 2 તો as a common factor આવી જ ગયું other than 1 and number itself. Okay, so but this contradicts the fact that a and b have no common factor other than 1. Why other than 1? Because what we had assumed is કે a upon b, where a and b શું છે co-prime number છે. co-prime number કોને કહેવાય કે જેના કોઈ factors જ ન હોય. that is not divisible by any other number other than 1. Whereas here it goes in the contradiction કે a અને b બંને 2 થી divisible થાય છે. a પણ 2 થી divide થાય છે, b પણ 2 થી divide થાય છે. So this contradiction has arisen due to our incorrect assumption. What we had assumed that it is a rational, it was incorrect, and so it is happening. So what we can say is this contradiction has arisen due to our incorrect assumption that root 2 is rational. So what we can say is we conclude that root 2 is an irrational number. Now if you have any other question instead of root 2, like root 3 is an irrational number, root 5 is an irrational number, then we will just replace the number 2 by 3, 5, 7 and so on. And wherever you can find the squares, so જેમ 2 no square here it becomes 4, so 3 no square 9 થઈ જશે, 5 square will be 25 and accordingly otherwise statements will remain as it is. Okay, so thank you for watching my video. For more such videos please like, share and subscribe. Thank you.